Here you see the question. In the question you see this double integration is not easy, so we use the change of order of integration. You see that the first integration, limits of first integration goes from x equals to 0. That means if this y axis and suppose this is an x axis, so x goes from 0 to x equals to 0 means x equal to 0 means this point x equals to 0 from, and if we draw x equal to upper limit is x equals to 1 minus y square. Graph of this will be this curve. This curve is x equals to 1 minus y square. So x equals to 0 is this line. So the first limit is from this line, from any point of this line to this curve, that is this horizontal strip. This horizontal strip represents these two limits, x equals to 0, here x equals to 0, to x equal to 1 minus y square. Now the second integration, you see limits y from y 0, from y equals to 0 to 1. This line is this line is y equals to 0, and this line is y equals to 1. Now we are going to change the order of integration. Here you see first integration, limits of first integration, a horizontal line. Now we do the opposite, a vertical line. You see the vertical line, and you see that this line goes from y equals to 0 to here. From this we can find, because this point also lies on this curve, so we can find y from here. Y will be 1 minus x over root. So the first limits of first integration will be 0 to 1 minus x over root, and the second integration, to cover this whole area, this strip, such strips goes from this point to this point, means 0 to 1. So the second limits of second integration will be 0 to 1. Now we write the same here. You see y sin pi 1 minus x whole square dx dy. This time, as you see here in the first integration x, this means that we have to integrate with respect to y first. Integration with respect to y, this means this y dy integration is y square by 2. If we put the limit, these two limits, then this will be 1 minus x by 2 minus 0, that is 1 minus x by 2. So here we remove the first integration and we write this thing for y dy 1 minus x by 2 sin pi 1 minus x whole square dx. Now we can write this thing as 1 by 4 0 to 1 sin pi 1 minus x whole square d 1 minus x whole square. And this thing, integration of this thing can be done if you assume 1 minus x to the power 2 as z, then this will be sin pi z dz. Very easy. So this will be minus cos pi 1 minus x whole square by pi, and limit is from 0 to 1. First, here 1 by 4 pi, if you take this pi out, first putting 1, this makes minus cos 0, so minus so here will be minus 1. Thereafter we put 0, putting 0, this becomes 1, so cos pi, so here will be plus cos pi, sorry, this will be plus, so here we put 1, this becomes 0, cos 0 is 1, thereafter minus sign, and cos pi is minus 1, so this becomes 1 by 2 pi. So 1 by 2 pi is the right answer. Hence A is our correct option.